Hello, my name is Gautam Aggarwal and I'm from India. I hold a bachelor's degree in environmental engineering and currently studying Master of Environment and Sustainability at Monash University. Today, I'm going to talk about my academic project that I undertook in the fourth year. I, along with a couple of classmates, carried out a comprehensive case study on the industrial air pollution in New Delhi. The main objective of our work was to determine the concentration of organic compounds and the different kinds of heavy metals present in the air in a large scale industrial area and subsequently gather evidence on the high levels of toxic particulate matter prevailing in this region. We started off by visiting an industrial area in Delhi and monitored the air quality by using an equipment called a respirable dust sampler, or simply an RDS. The RDS traps dust and particulate matter just like an air purifier. We placed a clean white colored fiber filter paper on the machine and let it run for 4 hours. The RDS was strategically kept near a metals workshop so that it could be exposed to the maximum amount of particulate emissions. At the end of its runtime, the fiber filter paper had turned completely dark gray, which indicated that it was full of dust and particulate matter. After this, we extracted the filter contents in our chemistry lab using a Soxhlet apparatus as seen in this picture, and chloroform was used as the organic solvent. Following extraction, we weighed the filter paper and its contents for measuring the mass of the accumulated dust. Since the average flow rate of the RDS was known, we were able to calculate the concentration of the total suspended particulates. Next, we took the filter paper for testing to Jawaharlal Nehru University. Here we made use of two sophisticated high-tech equipment, namely Energy Dispersive X-ray Fluorescence, or simply EDXRF, and GCMS, which is Gas Chromatography Mass Spectroscopy. The EDXRF was used to compute the various kinds of heavy metals present in the filter paper, while the GCMS was used for a qualitative as well as quantitative analysis of the organic compounds in the filter content. From the GCMS, we found out that diphenylconazole was the most abundant organic compound, comprising almost 69%. Certain organic compounds like hexatriacontane and tetrapentacontane were observed to be scattered all across the filter paper as they appear several times in the test report. The results obtained from the EDXRF tell us about the high presence of heavy metals such as zirconium, lead, copper, barium, nickel, strontium, iron, and silver. There have been known to be many harmful effects of these substances on our health. For instance, excess cadmium in lungs causes osteomalacia and lung cancer. Excess mercury in our body leads to stomatitis, nausea, and nephrotic syndrome. Lead causes anemia, vomiting, encephalopathy, which is basically a dysfunction of the brain. Furthermore, hemolysis, which is destruction of the red blood cells, and acute renal failure are associated with large amounts of chromium in the body. In the end, from all the data and information collected and analyzed, and with the evidence gathered, I would like to conclude by saying that there is a lot of work that needs to be done by the governments around the world to take strict action against the industries which are exceeding their maximum emission standards. They need to implement stringent policies and enforce through regulation and monitoring. At the same time, the cooperation of industrialists is also very essential in achieving the required target levels of industrial air pollution. Also, at an individual level, creating public awareness to increase the sensitivity of the problem can go a long way to deal with the ever growing problem of industrial air pollution. For now, we can expect that it will still take many years, possibly decades, before we see any significant improvements in industrial air pollution. Thank you.